Okay, guys, we are back into our Kubernetes cluster, and you can see here I'm logged into the control plane via SSH. Again, you don't have to do it this way. You can actually copy the kubeconfig to SCP it to your local Linux machine or Windows machine, and place it in the basically the root directory, the home directory, in the .cube directory as the file named config. And that will allow you to actually access the cluster remotely from a remote machine. But today we're actually going to continue on through PuTTY. Again, I'm puttied into the control plane node that we did. And let's just start with kubectl get nodes. Okay, and you can see here again we have our k8s control plane and our k8s worker node. And you guys should know, based on the blog post before this video, what Kubernetes services run on each and what roles those services represent. Okay, it's you need to understand those things first. Those are fundamental architectural things. I just think it's easier to stand up a cluster and then walk you through what that looks like within the cluster, not just reading documentation and looking at diagrams, but also what does it look like in a real cluster, and that's what we're going to talk about now. So let's start with doing kubectl get pods dash all. And you saw me do this last time, but I'm going to walk through this real quick. You can see here the namespace kube system. This is where most of the services run for Kubernetes, okay? Let's disregard the networking piece. We're going to have a whole section on networking, some of the other services like core DNS, etc. But let's focus on the services that we outlined in the blog post that make up a Kubernetes cluster. So you can see here first we have the etcd key value store that's running on this control plane node. I also mentioned that you can actually run etcd on its own or in its own cluster on separate nodes. Some solutions do that. Matter of fact, the Nutanix NKE solution does that for production. It actually creates a cluster of 3 nodes minimally for etcd. And that's your key value store that contains and manages all of your cluster configuration, etc. We talked about the API server a bit. The API server is probably one of the most important things, if not the most important thing within Kubernetes, right? Everything that you do with Kubernetes, I don't want to talk in absolutes, but most things you do with Kubernetes will be using the API server, not just the interaction of what we're doing. So this kubectl action is actually an action against the API server running on the control plane in the control node or the master node. Okay, and there's also components, right, that also talk to the API server. Okay, everything's done through APIs. Talked about the controller manager a bit, the proxy, right, and the scheduler, right, which basically schedules your pods or your applications appropriately based on specific criteria, right? It also monitors the health of your pod. So, for example, if a pod is down and you have a minimum deployment of 1 pod running at all times, what will happen is the kube scheduler will actually say, okay, this pod is down. We need to have a minimum pod or container, we call it a replica, of 1. And what it'll do is it'll restart the application to try to bring it up to a healthy state. This goes back to the declarative way of managing your applications, right? Where you create a deployment. We'll talk more about deployments a little bit later, and we'll get into some demonstrations of that. And you define all the criteria and the end state of the application, right? That's the declarative way of doing things. And when you do a kubectl apply, as an example, with that deployment model, right, against the API server, what happens is Kubernetes will look at that declarative YAML, we call it a manifest, right, that you create. And we'll get into more detail on manifest later too. I don't want to get too deep, but the reality is that manifest outlines all of your configuration for your application. and gets you to that state, right, that desired outcome of where you want to go with your application. That's the beauty of Kubernetes in general. But also, from a Kubernetes perspective, operationally, right, the scheduler is always looking at, going back to the scheduler, is always looking at, the health of your system, where to deploy pods if I had multiple nodes, and I had multiple replicas, right? Obviously, I'd want to spread those replicas of an application. So say I had 3 worker nodes, and I wanted to run 3 copies of my application or replicas of my application. It will schedule a pod per node, right, across those nodes by default. Now, you can do what's called tainting. I talked about that in my previous post, or the labeling, where you can label nodes to say, okay, these pods only run on these nodes. So maybe you have a GPU or an application that takes advantage of GPU acceleration. You only have 1 or 2 nodes that have GPUs. You can label those nodes and say, okay, these pods only run on those nodes. That's like node affinity, right? Very kind of similar. I don't want to say it's exactly the same. It's not, but similar to affinity rules with VM. VMs are more like, okay, I want this VM to run on these nodes or node all the time, or best case, right, etc. What we do is we use what's called taints and tolerations and labeling on nodes, right, to deploy pods, and the scheduler will utilize those to schedule the pods appropriately across the nodes. Okay, so again, etcd, the key value store API server, which takes all the commands, right. Basically, I call it the director, right. Kube controller, right, manager, that has to do with how it manages infrastructure, right, etc. on the back end, how it leverages that, your proxy, your scheduler, which we just talked about. All right. Now, there's also kubelet, right, which we talked about during the installation of this, right. So when we installed this cluster, we actually installed 3 packages. We installed kubeadm, which is a tool that allowed us to build the cluster. We installed kubectl, which is our tool, right, that our client tool that we're using, right, to access the cluster, basically against the API server, okay? And we also installed kubelet, all right? So kubelet you're not going to see here because kubelet is a service, all right? So what we're going to do is we're going to actually do a systemctl status kubelet, and you can see that this service is running. And remember, the service was crashing before we created the cluster. That's normal. So what'll happen is until you do a kubeadm init to build the cluster, to initialize the cluster, right, kubelet won't run normally. So now you see it running normally, and that's the other service, right, that runs. And then lastly, right, of course, you're going to need your container engine. So we do a systemctl status container D, I think we used, right? And the container runtime engine, right, is we're using what's called container D. Now, there are other container runtimes out there, Docker, etc. Container D seems to be the most popular one. It's kind of the de facto standard right now. The good news is they're all interchangeable, right? All interoperable. So if you create a Docker container, and that's something that I'm not going to cover in the Kubernetes piece. That's something I talked about right in the beginning, how you need to understand what a container is, maybe build some containers, right? Those types of things, create containers, etc. You can create a Docker container and it'll still run on a container D runtime. Okay, that's the beauty of container runtime engine. So those are the components there. Now, let's get into pods, and the only really way we can talk about this, other than looking at the system, is to deploy an application. So what we're going to do is we're going to deploy an Nginx application, very, very simple command. I'm going to do this imperatively. So there are 2 ways you can interface or interact with Kubernetes, right? You can do imperative commands, which I say, okay, this is the command, this is what I want you to do, run it, and it'll do it, right? Or you can do it declaratively, which is the preferred way, okay, where you can create a manifest or YAML specification file, outline everything you want in your application, right, and then create a deployment and deploy that specification. Now, what's great about that is you can do everything in that Kubernetes manifest. You can create your application, you can create storage volumes, persistent volumes, networking policies, services, you can create secrets, assign secrets. There's so many things that we're going to cover a little bit later in pieces, right? Because it can get very, very difficult. And that's just fundamentals, right? We're not even getting into the third-party plugins through things like operators and CRDs, which we will save for a later time. But again, we're going to do an imperative command instead of creating a YAML specification, which we'll get into in a future post. I think we'll probably cover that in the next couple weeks, is declarative management, declarative operations with Kubernetes. But what we're going to do is we're going to deploy this Nginx pod, okay? And we're going to stand it up and we're going to look at in detail at the pod, okay, a little bit. So let's do this. So I think I've already done this in the past, so I'm just going to do this. So you see that I had a K there. Remember, we talked about aliases last time. Now, alias won't last forever. Okay, alias will run out. So if I run this now, it'll run because I actually created the alias. So what you'll do is you'll just create an alias for kubectl and say alias k equals kubectl. And then if you hit that, that'll be an alias. Again, that'll help you if you decide to take the CKA exam. And also, you need to understand both the imperative commands and declarative way of deploying Kubernetes on your CKA exam, because imperative commands will help you do things much faster, especially small things like this, right? Which is basically just standing up a simple pod like Nginx, using an image, right? The latest Nginx image. I didn't define the image version. So when I say Nginx, right, it's going to go out and it's going to pull the latest version, right? And then in the namespace test, we talked about namespaces last time, and you can see here that pod Nginx is created. So what we're going to do is get pods Nginx, because that's what I named it, right? In the namespace test, this is very important. If you don't specify the namespace, I'll show you what happens. Nothing, right? Because it automatically goes to the default namespace, and we didn't deploy the application in that default namespace. We deployed it in the namespace test. So we have to define that when we want to look at information, right? So you can see here that Nginx is running. So that's good. So that means that pulled the image, right, and deployed the container within the pod. And let's look and see what that looks like. So one of the other commands, which is extremely important, is the describe command, because this is going to help you do a lot of things like look at events, do some troubleshooting. Matter of fact, the describe command is used at the very basic of troubleshooting, right? Pods, especially for the CKA exam. And you'll find that if you go through the Code Cloud course for Certified Kubernetes Administrator, the describe command is your friend, right? So again, you still have to do the namespace, right, to get the command to work, because that's where it was deployed. So I'm going to scroll up here, and you can see here I have the name Nginx, because that's what we named it, krun. So what run command does is it basically is an imperative command to run a pod called Nginx, use this image, right, and deploy it to this namespace, right? And that's what we did. So name is Nginx, namespace is test, the service count is default, the node is running on k8s worker, and you can see here another thing I talked about earlier is, well, Mike, why didn't it run on the control plane? Well, because when you create the control plane by default, it's tainted, right? The node is tainted, meaning it's labeled in such a way that it's doing control plane duty, so it's not schedulable for applications. Only the worker nodes are schedulable for that. Now, you can go in and remove the taint from the control plane, and you can actually schedule application pods. You know, that would be good for like a test or a lab if you want to have a single node that does the control plane and to run some, you know, testing applications. You could do that. I'm not saying you couldn't do that. And the reason why you do that is because, you know, it's simple, right? Maybe you don't want to have all these different nodes. You know, maybe you don't want to stand up a bunch of different VMs because you have resource limitations, etc. Those are other considerations, right, as you go through this process. But in our case, we have a worker node and a control plane node, and it automatically defaults to the worker node. It's the only worker node we have. If we had multiple worker nodes, the scheduler would look at where the best place to place this pod. Okay, that's what the scheduler would do, and we'll do more on multiple worker nodes as we go through clustering, as we go through scaling out your cluster, as we go through basically cluster operations. Okay, you can see the start time, the labels. Okay, automatically labels it Nginx, right? Because this is what we did, right? We did a kubectl run, and we called it Nginx, so it automatically labels it Nginx. The annotations, we're using Calico, which is our CNI. We talked about that. You have to have a container network interface installed in your cluster in order for the cluster to be usable. Okay, and you can see here that it automatically assigned a pod network, okay, of 172.16.254.133/32. Okay, that's the default network that Calico uses when you deploy the CNI. When we get into deeper networking, you can actually specify the pod networking IPs, okay, that you want, or the IP ranges when you deploy Calico through a resource definition. So don't worry about this right now. We're just using the defaults. When we get into networking, and by the way, networking will be probably one of the hardest things that we go through because of all the different layers that you have to go through, right? You have your node that has a NIC, right? A virtual NIC, right? The node is a VM, so it has a virtual NIC interface. You have the container, or excuse me, the pod networking. You have the container networking. You see where I'm going? This can get very difficult, very complex, very fast. And I find that networking, just like outside of Kubernetes, right, poses a challenge in a lot of shops, right, when it comes to how I manage networking, how I route traffic, how I load balance traffic against multiple replicas, how I load balance traffic, across clusters, how nodes in one cluster need to talk to nodes in another cluster, meaning applications, pods in another cluster. How does that work? So it can become very, very complex. I digress. Let's go back to the container. So you can see here, what is the containers, right? So it's Nginx. This is the container ID. The image is Nginx. The image is pulled automatically from the Docker hub, okay? And it doesn't need to be done there. You can specify a registry, an image registry, where you pull your images from. As a matter of fact, you will do this in production. You will not pull things from Docker Hub. Docker Hub is public. More than likely, in your production environments, right? I want to say more than likely, 99.9999%, okay, should be using, really 100%, should be using a private registry. Okay, that registry contains all of your images, your container images, meaning your application packages, right, that your Kubernetes solution can pull from. And we haven't defined a third-party registry to do that, so it automatically defaults to Docker Hub. Okay, it gives you port. So we didn't specify any ports to access this application. Again, we're not going to access it yet. We're not going to go through that yet until we get to the networking piece. So we didn't specify that in our imperative command here, right, on this krun. And we could have specified the port and the host port. Okay, and then what I could have done is I could have did a port forward of the local host, which is my machine, right, or this machine, to that port, and access that through the node network on that port. Okay, so the node network is the IP of this node, and then we could have did a colon, whatever port it was, and we could have got to the Nginx, and we'll do some of that later in the networking section. You can see it's ready. It hasn't restarted, and you can see the mounts. Okay. The mounts are var run secrets Kubernetes service account from kube API access chcgr. So this is a read-only service account that's already created, right, from kube API access. You can see the conditions, the status, right? It's initialized, it's ready, containers ready, and pod scheduled. This is exactly what you want to see on a healthy pod, a healthy application. Okay. What volumes is it using, right? So again, it's not using any volume in a sense for the application as you would think an application would use a volume, right? It's not using a volume per se to store data because it's a stateless application. I don't have any persistent volumes, and it's another section we'll cover on storage when we talk about PVCs, okay, persistent volumes and persistent volume claims, where we provide real storage, right, back to your containers for persistence. So if you require state, like a database as an example, you would require persistent storage. And in this case, Nginx is running stateless, right? There's no real storage requirement other than this volume created for their certificate, right, for the config map. The k8s is best effort. You can see here the node select. So remember, I talked about node selection. So I could have put a selector to say, okay, only run on this specific node or set of nodes. And you can see here the tolerations, right, are node.kubernetes.io, not ready and unreachable. Those are the tolerations. We'll talk about taints and tolerations in another section. Again, that'll be another piece of understanding how to manage your nodes and operating your nodes. So let's look at the events because it's very important. So you can see here it successfully assigned the test Nginx, right? And you can see here test/Nginx. So you'll see this in a sense that this is the namespace, this is the name of the pod, all right? And it assigned this to the k8s worker node. It pulled the image, the latest image Nginx, because I didn't define a image version. So it will pull the latest. It successfully pulled the image from Docker Hub, right? This is how long it took to do that. It creates the container, and it starts the container, and it did that in 113 seconds, right? So we have an application up and running very, very quickly. Now, this is the other power of containerization, Kubernetes, which is orchestrating all this, right? So you have the container side of it, which is your package application, and you can bring up a container even outside of Kubernetes fairly quickly. But to do this, schedule it, right? Make sure it's on the right nodes, make sure it has the right networking, right? And a bunch of other things that we'll talk about later, like we talked about storage, if it requires persistent storage, if it requires a service account, if it requires secrets, right? If it requires multiple replicas, right? Where you define a minimum replica and maximum replica. You can define CPU, memory, limits, reservations, etc. So there's a lot of things you can do within your specification to deploy an application and have it done. So imagine doing that in a VM, you create a VM. Now I know there's automated ways of doing that where you can create a VM through Terraform as an example. And I'm sure you've heard that HashiCorp is being purchased by IBM. So hopefully you guys are looking at Tofu, which is the fork of Terraform, the open source fork of Terraform. Because of course IBM will make it commercial and you'll have to pay for it, unfortunately. So going back to Terraform, you create the VM with Terraform. Maybe you use something like Ansible, right, to do a configuration on the virtual machine, right, and then you need to deploy an application, etc. It becomes cool. It's still a lot of steps, still basically multiple tools, right? And here, the developers creating a package, right? And as Kubernetes operators, our goal is to make sure that that package is delivered in the way that the developer intended, right? With all the performance, the logging, the monitoring, the telemetry, right? And all of the IAM, the secrets management, all of these things pulled together declaratively when we walk through the declarative way of doing this, right? And then deploying that application and having it be so fast on deployment, having it be able to recover quickly, right? Being able to do maintenance fairly simple, right? So that's the value of Kubernetes because it orchestrates all of that. And it does so much more because people are like, well, when we start talking about operator framework, which I believe is one of the most powerful things, it's good and bad in the sense that it's good that I can now use an operator framework to tie into third-party, right, systems without having to have Kubernetes natively support it, right? I can build an operator, or a third party can build an operator to tie into their systems. So, for example, with Nutanix as an example, we have what's called an NDB operator. So we have Nutanix Database Services, which is like an RDS on-prem, right? And we can tie in to Kubernetes using the Nutanix NDB operator, right? So you can build a database and have it deployed, declaratively, and have it call through APIs the NDB service on Nutanix and deploy that database for your application. So that's just one example, but there are operators all over. The problem, when I say good and bad with operators, the problem with operators, and we'll talk about that too a little bit later, is when we get into more of the advanced topics and the integration topics, is that when you do upgrades of your cluster, you have to make sure that the versioning and everything aligns to the operator versioning. Did the operator get updated with the Kubernetes version, right? All that has to have to interoperability, so that becomes can become challenging if you have a lot of operators within your environment. Okay, I know I went off on a tangent, but again, this is a quick way of just showing you what it's like, right? This is your pod, your Nginx containers in your pod. It's scheduled right on your worker node, and again, if we go back to kubectl get node or get pods dash namespace test, you'll see that Nginx is up and running. You can also get details on the node. So if you do like an O-wide, right, you'll get more details on some of the nodes, right? You can see here, I think when we just do without the wide, right, we just do like this basic, right, gives you the version. But now if I do O-wide, it gives me the IP address of the node, gives me the OS image, right, the kernel version, and the container runtime version, right, container runtime engine, and the version that's running. So you get a little bit more details. Again, I'm kind of jumping all over, but I wanted to show you guys within the cluster, right, going through all of the foundational services, the API server, etcd, controller manager, kubelet, kube proxy, as well as the scheduler, the container engine, right? Those are all your foundational pieces for a basic Kubernetes cluster to even get everything working and running. So I wanted to show you guys that. I wanted to show you what it looks like within the cluster. And I hope you enjoyed this series. Next week, I think we'll get into a little bit more on maintenance. I want to focus on cluster operations and maintenance before we get into actually applications. That's extremely important to understand. And so we'll do an upgrade of this cluster. We'll keep Nginx running on this because we're going to have to, I'm actually going to deploy another worker node. We'll do that. We'll do 2 replicas. We'll create a deployment with 2 replicas, or create a replica set of Nginx. So I'll have 2 Nginx pods. And we'll show you what it looks like to actually upgrade the cluster and go through a drain. When you drain the nodes, basically, think of draining the node like you're doing a vMotion of VMs into, a live migration of VMs into another node as you go through maintenance operations. It's not the same, right? Because I'm not live migrating anything. I'm actually just making sure that I'm bringing pods up on another worker node as I go through the upgrade process, right? So we'll get into more cluster operations, cluster maintenance. We'll get into a little bit of logging. We'll go into a little bit deeper dive on the node itself. There is a way you can do what's called a static container, which you can actually build a container by logging into the node itself and creating a container within a directory on that node. We'll talk about that, when to use that, or when folks use that. It's very rarely used. We'll talk about some troubleshooting, right? One thing I will be using is some Code Cloud free labs, which I will show you how to access those. Those free labs will allow us to do some troubleshooting, some steps. As a matter of fact, you don't even have to do this. You could actually go into Code Cloud and actually do some of the stuff I'm talking about. But it's good to actually stand up a cluster, like I said, manually, so you see what the process is and get an understanding of that. So again, I hope you had I hope you're having a great weekend, and I hope you're enjoying this this series, and and you're learning some things. I thoroughly enjoy helping folks out. So if you have any questions, you can reach out to me through the blog. If you have any comments, I would ask you to make some comments. Anything you want to see further, right, or you have questions on or want to get more details on, don't hesitate to reach out to me on the blog. You can comment on all the blog posts, and I will respond to you accordingly. All right. Have a great rest of the weekend and a great productive work week. I'll see you next time. Bye-bye.